Okay, this is, we're going to do another force diagram for an object. In this case, it's going to be this 100 kilogram, I'll keep calling it a crate, like a box. And notice that there's something weird going on here, which is that there is an elephant sitting at rest on top of our object. So we're going to follow the same 5-step process, but we're going to have to use something, it's a silly name, but I call it the elephant rule in order to figure this out. Okay, so let's get started. We know our object is the crate. Done. We're going to do a force inventory. So let's get started with that. So I'll do that down here. Force inventory. Okay, so the earth pulls down on everything on the earth, and it's going to pull down on our object. Don't get distracted. I know the elephant is more interesting than the crate, but our object is the crate. So this is going to be a gravity force, and it's going to be the earth pulling down on our crate. And now what size is that force? So we have this formula that says, okay, take the mass of your object times 10 newtons of gravity force for every kilogram. And so we're just going to say, what is 100 kilograms times 10 newtons per kilogram? That's 1,000. So that's 1,000 newtons. That's a little over 200 pounds. And that's going to be down. Okay. Now, what else is going on? So sometimes it's helpful to kind of in your mind or actually on paper is to draw a dashed line and to see what's touching our object, because that's going to help us. Okay, so I see two things touching. That more interesting elephant and the floor. Okay, let's do the elephant, because this is going to cause us to use the elephant rule. So the elephant is pushing down, so we're going to call that a normal force. Again, I said it a bunch of times, but that's a weird name for just a typical pushing force, and it is the elephant. Now, how hard is the elephant pushing down? That's the question. This is what we're going to use the elephant rule. What is the elephant rule? The elephant rule says that it's a little dark here, so it's a little dark, so I'm going to go for bright pink, I guess. If the earth pulls down if the gravity force on the elephant is, just make up 1,000 newtons, that's like 220 pounds. And the elephant isn't accelerating, that means the elephant is going to push down on the bench with a force equal to its weight. Just imagine this elephant was sitting on top of you. How hard would the elephant be pressing down on you? Well, if it's not accelerating, it's going to press down with a force equal to its weight. That doesn't seem too surprising, I think. But the thing is, we don't want to call this a gravity force. Yes, the earth pulls on the elephant, but we don't want to list this as another gravity force. The earth's pull causes the elephant to push down on the crate. And pushing forces are normal forces. But I can know, so if we know the elephant's mass, it's very easy to come up with its weight, right? We multiply this by 10. So the elephant is pushing down on the crate with 10,000 newtons of force, and that's going to be down. Now, what else is happening here? Well, there's a floor, and the floor is pushing up. I don't know how much that is, but that's what we're going to use our force diagram to figure it out. So there's another normal force, and it's going to be the floor, and I don't know what it's going to be, but it's going to be up. Okay, we are now ready to draw our force diagram. Let's go do it, because I got to get to class. So we're on step 3. So I'm going to say my object is a dot. Now, in this case, you know what? I'm actually going to just make an outline of the box. because I think it's just going to be easier to explain than a dot. So I'm going to take away the dot. So since it's a nice, easy shape to draw, I'm just going to keep the basic shape here. In fact, I'm just going to go ahead and go all the way and say, we don't need dashed lines, so let's do the whole thing. This is our crate. So I'm going to start putting the forces that and you'll see, hopefully you'll see why I made it a box instead of a dot. We're going to draw arrows to show, now we're on step 4, draw arrows to show the known forces. Okay, I've got 2 known forces and they're both down. So I'm going to start with, I'm going to be careful here because if I start with this 1,000 newtons, like if I say, oh, that's 1,000 newtons long, then look at what I have to do here. I have to make this guy 10 times bigger. I don't want to draw that. So I'm going to always start with the biggest force so I don't end up having like ginormously long arrows. So I got 1,000 newtons. No, I'm going to do the 10,000. So I'm just going to say, this is the elephant pushing down. So the elephant's pushing down with 10,000 newtons. So that's the normal force of the elephant. And that's 10,000 newtons. That's 2,000 pounds, a little over a ton, maybe 2,200 pounds. That's a lot of force to be pushing down, if that was you. Okay, then I've got a smaller, much smaller gravity force. So I'm just going to draw that here. I don't put them on top of each other. There we go. So that's going to be the Earth, and that's going to be 1,000 newtons. Now, done with step 4 because those are the 2 forces that I can figure out the magnitudes of, the size of the forces. Then I got this floor pushing up. Let's make that blue. Okay, how big should this force be? I know it's going to be up. Well, this is where I go back to my Newton's laws that we've learned about, and I say, oh, the acceleration of this box is 0. So that means all the forces acting on the box, not the elephant, all the forces acting on the crate have to add up to 0. So I need as much up force as I have total down. Well, what's my total amount of down force? I got 10,000 newtons from the elephant pushing down, and I got 1,000 newtons from the Earth pulling down. Well, that's 11,000 newtons. So that's how much force I need. So I'm going to try to make, no, we don't want red, we want blue. I'm going to do my best to make this blue arrow kind of as much up as the total length of these arrows down, but I'm not going to be too picky. But I can see that it's a little bit longer than the green because I have to also push up that much harder. Anyway, so that is the normal force, and that's going to be the floor, and it's going to be 11,000 newtons. So if the question was, hey, how hard must the floor be pushing up? This kind of makes that question easy. You say, oh, 11,000 newtons, because it's got to counteract the total downforce of both the elephant pushing down and the Earth pulling down. All right, so this is how we use the elephant rule.